Okay, the same rules apply, now that you can see, the same rules apply to when we're working with the headstock, because we'll get my blue pin out because we haven't used that. I want this axis on the chuck to be central on my broom handle the whole way down the lathe. And what happens is I've got one bolt here, there's this pivot pin in the centre here, and there's some jacking bolts in the back, which we might be able to show you later on, which I probably will show you later on if I remember. But what happens there is that when I'm working with the chuck, particularly the 4-jaw, 3-jaws, if you're working with the 3-jaw, you're often working on short distances and stuff that's not ultra critical. But when you're working with the 4-jaw, and you do, that's when I'm generally, if I'm working with the 4-jaw, I'm generally looking for a high degree of accuracy, and occasionally I'll actually get the micron gauge out to go for a centre. And when you're going, and that's after I flip something around, obviously, you don't put a micron gauge on a bit of peeled 4140 or something like that, you know. It's already got to have a true surface that's been machined to centre. So what I find with this lathe is that I need to check it again. I've never adjusted the headstock bearings in it, and last time I played with it and I had a piece of material in the jaw, what I noticed is that when I applied pressure to the material, when I say the jaw of the chuck, when I applied pressure to the material with the dial gauge on it, there was quite significant deflection in the material. Now what I didn't do was I didn't have time to muck around at that point in time to see whether it was the chuck or the headstock bearings, but either way it's reasonably easy to work out. Go from 3-jaw chuck to the 4-jaw chuck, and if I'm the same distance off the headstock to the material, I'm getting the same deflection, well then it's headstock bearings, because the chances of both chucks being equally bad is pretty small. So that's what I'll be doing, and if it is, well then we'll just do a headstock bearing adjustment. The lathe hasn't got a lot of hours on it, so it's not a big deal. And the other thing there too is if you're turning between centres, it doesn't matter. It just doesn't matter, because it's working off a pivot point here, it's working off a pivot point here up the other end where you can't see, but namely the tailstock. So it's working point to point. Now, as long as those 2 points are relative to each other, it doesn't matter. And the other thing too is, look, if I'm working out here, let's show this. Okay. So I put this hanging out in the breeze unsupported. Now let's say that I'm coming along here and I'm running the tool down along here. What I've actually got, and you can see it in the wood, at least I hope you can see it. There we go. You should be able to see that. What we've got here is we've got deflection. Now, if I've got a piece of steel in there, or a piece of HDPE or whatever, it doesn't matter, the same rules apply. It flexes. So if this here isn't exactly true, if this here has got a couple of hundredths or a couple of microns, a couple of hundredths is getting a bit excessive, but if this has got half a hundredth of movement in it, it's not that big a deal. What is a big deal is that this centre axis and my tailstock axis are the same when it's loaded. Now, what I've got on this lathe is I can put a piece of 32mm, which is about 1.25 inches. I can turn 32mm from end to end. It's a 1 metre machine. I can hold it in the 4-jaw at this end. I can have it centred at that end, and I can't measure any taper using a metric mic. Now there's 2.5 hundredths or 2.54 hundredths of a millimetre to a thousandth of an inch. Now I can't measure deflection when I'm on a line. I'm not half a line either side of it. I'm on a line. But there's a couple of things I need to do with that. I run coolant when I'm doing it, and I've got a sharp tool. 3 things: a coolant, sharp tool, and a light finishing cut. And then I can't measure anything over the length of the lathe when I've got it set up correctly. I haven't done that since I've moved, and so I'll find out. I've got a piece of I've got some hot roll mould steel there, which I might have a go at when I set it up. Now, people tend to do a test bar, and people love test bars, and I think test bars are a good thing. But, and I'll use the word but, I'm just saying if we're fully wide, there is a limit to a test bar. Test bar invariably is 2 points. But the reality is we don't machine at 2 points. Just if you're right at one, if I'm right here at the chuck and I'm right here at the tailstock, I might have a twist in the bed which is equal, but in the centre of the bed I could be significantly away. You know, that significantly might be 1 thou, might be 2 thou, might be 5 thou, depending on your machine. It could be 20 thou if you've got an 8 metre bed. So what you have to do is you have to decide at what point in time are you happy with your setup, because your setup is dependent on the work you are doing. If I'm always working in this area of the lathe, I don't know why I've got a 1 metre bed, but in reality most lathes work within the first 300 mils where most of the work happens. Doesn't matter whether it's a hobby lathe or a big lathe, most of the work tends to happen in the first 300 mil. On very big lathes it probably happens in the first 600, but you're always spending most of your time working up to a flange and in and out. This is your point that you're working at, and as you get out you spend less time working there. You might be working on a faceplate which is, and when I say the first 300 mil, I'm talking 300 mil from the end of your chuck or the end of your faceplate or whatever. You might be working on a lathe which has got a 2 metre, 2 metre, 6'6" thereabouts faceplate on it. But you're still going to be working in that first 600 mil on something that big most of the time, because that's where you're coming down to your flange, isn't it? You always spend most time at the headstock end. It's just the nature of the beast, because your job lengths vary. So that bit of rant finished. That's the basic science behind why we set up the lathe and why it's important to set your lathe up. Short lathe, say 1/2 metre of usable bed, 18 inches. A hobby lathe or a specific function lathe quite possibly is only going to have 4 mounting points, 2 at each end. So what you're doing is you're chasing the twist. My other lathe over there, the old girl, it's about a 3-foot bed, still only got 2 mounting points at each end. It twists, it's as supple as butter. It's like hot butter in the sun, it moves all the time. This way it's not too bad, if we ignore the wear, but when it comes to twisting it, not a challenge at all. When we get into other stuff, bigger lathes, I was, some time ago now, I was at Lathe looking at their steam workshops. They had a bed there, a lathe there, a flat bed, which they turned into 2 lathes. But when it was originally shipped to Australia from the UK, it was an 80-foot bed. That's right, it was 80 feet long. And that was sitting here in Western Australia. Though since then we've had a serious bushfire, and Yarloop was burnt off the face of the map, unfortunately. There was a couple of lives lost, and I've mentioned in a previous video. But the lathe, what it was done was it was broken into 2 pieces, and they made 2 40-foot lathes out of it. But it was used for making naval guns they used to, it was used for making naval guns in World War One. They were shipping guns here to Western Australia, and they were machining these naval guns because it had the length of bed and it could do the job. So it's an interesting bit of trivia, but it's unfortunate that so much history was lost in the fire. I haven't been down there to have a look now, since, but I like to go down just to have a look at the remnants. Very, very, very sad situation. So we might move around and we'll look at the other end of the lathe now, and I'll show you where those adjustment screws are for moving the headstock. So this is the headstock end of the lathe with the cover off. I've been a very bad boy. The safety's been bypassed. That is normally out of the way because that actually runs through the cover. Actually, just going to flip that over so I can see what you can see. Okay, so you don't have to worry about that rubbing on the belt. Although I could position it a little bit better, tidy things up a bit. I tend to keep a fair bit of grease on here because I don't get in here very often. The actual, you've got a lock bolt here, and there's another one up here behind the skier. I'm going to strip the skier off. Now, this here is the adjuster, and there's a jacking bolt here, and it's got a mate on the other side. So what happens is you loosen the two locking bolts off on the front, you loosen these two off, and then you jack it on this because you got the jacking point at this end of the rear, and at the front you've got a pin sticking up, and so it pivots on the pin as you jack it. Now you don't have to make significant adjustments at this end because at the other end, a metre out of the chuck, a tiny movement here is a very significant movement at that end. And what you find is that as you tighten these up, your adjustment moves. So you chase it, and you chase it, and you chase it. And again, it gets down to the oldest story in the world. At what point in time you think it's sufficiently accurate for the job you're doing. There is no point trying to get microns on the other end. If it's a couple of microns, who cares? Because then you're starting to deal with thermal deviation. And when you think that in round numbers there's 2.5 microns to a 10,000th of an inch, yeah, we're starting to get pedantic, excessively pedantic. So I'm just zooming in a bit. I'm hoping that the focus will come in. Yep. So you can see the head of the bolt here at the end of my finger. This block here is on a little bit of a pivot. There's another locking bolt up there, so there's two bolts there to hold this block in position. It's got an equal mate on the other side. Yes, you can just see the head at the end of my finger here. So that's how you adjust it to get it true over the end. By memory, let's zoom out a bit, see if it's in shot. Yeah, it is. You take this cover off, and behind here is my headstock bearing adjustment. So all I have to do is take this off, undo the lock nut, nip up the headstock bearing to put a little bit more preload on it, and lock it up again. So that's all I need to do up there. I've got a bit of oil on my finger. I was just looking for somewhere to wipe it up in my clothes. Okay, we're back with a bit of dirty rag. I probably should get in here a bit more often. There's a bit of mess in here, but while we're here talking about it, change gears. This machine is actually quite simple as far as doing change gears go. When I'm doing metric threading, I work on the innermost gears. When I'm doing imperial threading, what I have to do is I have to take this gear off and flip it round, and it runs. This still drives on the innermost gear, but this bottom gear drives on the outermost for imperial threads. There are a number of different gears that come with it. You have to mix and match and that sort of stuff, but basically when you're running imperial threading, it's one inner, one outer, and when you're running metric threading, it's both inner. So it's pretty easy. It's a pretty easy machine to use as far as that goes. But we've digressed. Because I've got to have all this off when I set it up again, what I do is I get a piece of 80 gram paper, 80 gram a square metre. I don't know what that is in, off the top of my head, I don't know what that is in imperial numbers, or in you know, ounces per square foot, or whatever it's gauged in, but basically it's just a standard sheet of A4 or A5 paper. Letter, doesn't matter, just your ordering piece of paper that you throw in your photocopier. And I'll peel off a couple of pieces of that, and I'll put one between each gear mesh, feed it in, slide it in, and what happens is the head of the tooth pierces through it. Who cares? Because what I'm after is I'm after the flank clearance. I'm after the side of the tooth, the side of the teeth. And what that does is by feeding it in, this is still floating up and down, I'll get that in, I'll lock this up tight. This has got proper bearing race in it, and then when I'm happy it's all centred, I lock that up and then I turn it, and the pieces of paper come out and they're pierced through on the sharp edges of the teeth, as in on the points of the teeth, it's pierced through them, but the contact between the teeth is obvious. There's the contact where it's squeezed the paper on the large surface area. It doesn't punch through, so it gives you clearance. You can play with it a little bit. Some people might decide that on the small lathe you might find the cigarette paper folded in two might be how you do it. But the beauty of that is you're not trying to move stuff up and down. You just push it in. It compresses the paper between the flanks of the teeth, and you've got clearance. And if you happen to find a favourite piece of paper, you might find that for your machine that 40 gram paper is the ideal thickness, or if you're on a very large machine you might find 120 gram paper is the go. But that's what I use for a gauge, and it folds to shape and applies the teeth, and everything gets easy. What are these? Looking at those, these are probably module, I don't know, I'd have to have a look. They're somewhere between 1.5 and 2, just having a quick look at them. Let's sit down and work it out. Incidentally, another little hint which you can't see at the moment, might be able to bring you around and zoom in. Yep, you can see it now. When these turn up, the gears aren't marked, so what I've done is I've counted the teeth on every gear, and I've just taken them with a little engraver and I've engraved the teeth on them. This big one I don't worry about because it's the only big one there is, but also this little one will be marked somewhere. I think that's a 30 by memory, but it'll be marked somewhere so that you know what it is.